Hello, everyone. We are starting 1.2.2. So this is the second lesson in our second investigation. It's called Up and Down the Staircase, Exploring Slope. So just to get us started here, linear functions are often used as models for patterns in data plots. In Moving Straight Ahead, that was the book that you should have used in 7th grade, you learned several facts about equations representing linear functions. Those facts are any linear function can be expressed by an equation in the form y equals mx plus b. The value of the coefficient m tells the rate at which the values of y increase or decrease as the values of x increase by 1. Since m tells you the change in y for every 1 unit change in x, it can also be called the unit rate. A unit rate is a rate at which the second number is 1 or 1 of a quantity. The value of m also tells the steepness and direction, either upward or downward, of the graph of the function. The value of b tells the point at which the graph of the function crosses the y-axis. That point has coordinates of 0 and b, so b is whatever number that you find for where it crosses the y-axis, and it is called the y-intercept. In any problem that calls for a linear model, the goal is to find the values of m and b for an equation with a graph that fits the data pattern well. To measure the steepness of a linear equation graph, it helps to imagine a staircase that lies underneath the line. So here we have a picture of a staircase. We have a vertical change and a horizontal change on each stair. The steepness of a staircase is commonly measured by comparing two numbers, the rise and the run. The rise is the vertical change, so right here on a staircase, from one step to the next, and the run is the horizontal change from one step to the next. So the run becomes what you step on. The vertical change is where you lift your leg. The horizontal change is what you step on. The steepness of the line is the ratio of the rise to the run. This ratio is the slope of the line. So the slope is the vertical change over the horizontal change, or the rise over the run. You'll be hearing us use a lot of rise over run this year, but just think of it as a staircase. You're going up, and then you're going over. You lift your foot up, and then you lift your foot or put your foot down on the stair. As you can see in this diagram, we're looking at the line that connects the points of the stairs. So you're going up and over. So rise and run, rise and run, rise and run. In the diagram of the staircase, the slope of the line is 2 over 3. The y-intercept is 0, 20. So the equation for the linear function is y equals 2 over 3x plus 20. So in this case, m is 2 over 3. So the rise is 2, the run is 3. Rise is 2, run is 3. And then the 20 is where it crosses the y-axis. Here we can see that from this point 0 to where it crosses the y-axis is 20 inches. So that makes our y-intercept 20. Now in this lesson, we're going to be looking at equations and how to find slope in the y-intercept. So as soon as you're done with this video, you can click out of it and go on to the Explorer.